Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're continuing our journey through the synchronization utilities season, focusing on the locks and conditions chapter. We'll be diving into ReadWriteLock, a powerful tool in Java's concurrency toolkit.
Hello everyone, I'm excited to explore ReadWriteLock with you all today. Before we start, listeners should be familiar with basic threading concepts and have a good understanding of the lock interface and reentrant lock, which we covered in our previous episodes.
Absolutely, Victor. To kick things off, I have a quiz question for our listeners. When would you choose ReadWriteLock over reentrant lock? Think about that as we go through today's episode, and we'll reveal the answer at the end.
That's an excellent question, Sheila. It really gets to the heart of why ReadWriteLock exists and when it's most useful. I'm looking forward to unpacking that throughout our discussion.
Great. Let's start with the basics. Victor, could you explain what ReadWriteLock is and why it was introduced?
Certainly. ReadWriteLock is part of Java's concurrency toolkit. It was introduced to handle a common scenario in programming where you have information that's often read but rarely changed. The key idea is to allow many threads to read at the same time, but only one thread to make changes.
That's interesting. So it's like a more specialized version of a regular lock. Can you give us a real-world analogy to help visualize this concept?
Absolutely. Think of a library with a popular book. Many people can read the book at the same time without interfering with each other. But when someone needs to update or repair the book, they need exclusive access. ReadWriteLock is like the librarian managing access to this book.
That's a great analogy. So, how does ReadWriteLock actually work? What does its structure look like?
ReadWriteLock gives us two types of locks, a read lock and a write lock. The read lock is like a library card. Many people can have it at once. The write lock is more like the librarian's master key. Only one person can have it, and when they do, no one else can read or write.
I see. So, if I understand correctly, you'd use the read lock when you're just looking at data, and the write lock when you need to make changes.
Exactly right, Sheila. This separation allows for better efficiency in situations where we read data often, but update it rarely. Multiple threads can read simultaneously, speeding things up, while still keeping our data consistent when updates happen.
That makes sense. Are there any specific versions of ReadWriteLock that we should know about?
Yes, the most commonly used one is called reentrant ReadWriteLock. It's reentrant, which means a thread can get the same lock multiple times without getting stuck. It also offers a fair mode, similar to what we discussed with reentrant lock.
Interesting. Could you tell us more about this fair mode? How does it work with read and write locks?
Sure thing. In fair mode, threads get the lock in the order they asked for it. It's like a queue at a store. First come, first served. This prevents any thread from being left out forever. However, it's worth noting that being this fair can slow things down a bit, so we need to use it wisely.
I can see how that could be important in certain scenarios. Now, you mentioned earlier that ReadWriteLock can improve performance when we read data often. Could you give us an example of when this might be particularly helpful?
Absolutely. Imagine a website that shows product information. The product details are stored in a cache, which is like a quick access memory. Many users might be looking at products at the same time, but new products are only added occasionally. Using a ReadWriteLock here could really speed things up compared to a standard lock, because many users can read product info at the same time.
That's a great example. Are there any traps or common misunderstandings about ReadWriteLock that developers should watch out for?
Good question. One common mistake is trying to upgrade from a read lock to a write lock without letting go of the read lock first. This can cause a deadlock, like two people each waiting for the other to move out of the way. Another is underestimating how much overhead read-write locks can have when you're doing a lot of writing. In those cases, a simple lock might actually work better.
Those are important points to keep in mind. Do you have any tips for using ReadWriteLock effectively?
Certainly. First, always release locks in a finally block. This ensures they're released even if something goes wrong. Second, try to hold on to locks for as short a time as possible, especially write locks. And third, consider using methods that try to get the lock with a time limit to avoid getting stuck waiting forever.
Great advice, Victor. Now, as we're nearing the end of our episode, let's go back to our quiz question. When would you choose ReadWriteLock over Reentrant Lock? Can you reveal the answer?
Of course, you'd choose ReadWriteLock when you have information that's read often but changed rarely, and when you want to allow many readers at once. This could be in situations like catching systems, settings management, or any scenario where you have many readers and few writers.
Thank you, Victor. To wrap up today's episode, ReadWriteLock is a powerful tool for managing access to shared information. It allows many readers but only one writer at a time. It's especially useful when we read data often but update it rarely, and can really improve performance in these cases. However, it's important to use it carefully and be aware of potential issues like lock upgrading problems.
Excellent summary, Sheila. In our next episode, we'll be discussing the condition interface, which works together with locks to give us even more precise control over how threads work together.
Thanks for listening, everyone. If you found this episode helpful, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth, educational content. Until next time.